Hi, my name is Lizzie. I am a junior chemistry BS and Korean double major. Um, and I am somebody who is very passionate about teaching, and I am very passionate about chemistry. And I hope to pursue a PhD in chemistry in my future to become a professor of chemistry. So, this being in LA is just the start of a long journey into a career that I so dearly cherish and want to be a part of. Um, I really want to help students with their note taking strategies. It really starts before the class. So that means reading your textbook and annotating your textbook, looking over the slides. All of these things come together to make class just a little bit better, and a little bit more where you can test your understanding instead of seeing things for the first time. And this really helps with memory, and it helps with being proactive with your studies. And this leads to less stress around test time. You know that Chem 101 can be stressful, um, but keeping yourself accountable and proactive is one really good way to make this class just a little bit less stressful and a little bit more fun. Even though it's so fun already, just, it's helping. Okay, so I want to talk about hybridization today. Hybridization is very useful. Hybridization is basically the mixing of atomic orbitals to form hybrid orbitals, which are better suited for bonding. So, we usually like to deal with three different types of hybridized orbitals, and we'll have like sp, sp2, and sp3. So I'm going to go through those briefly. And yeah, so I'm going to start with sp3. Right here we have a beautiful methane molecule. We love methane, she's so pretty. So methane is a carbon bonded to four hydrogens, and we know that carbon has four valence electrons, and it tends to make four bonds to hydrogen. But in its ground state, there's only two um, there's only two unpaired electrons for bond making. So how does carbon make these four bonds to in methane? So this has to do with our hybridization. As we can see here, we are taking a 2s orbital, and we're taking three 2p orbitals, combining them together, and we're going to make 1, 2, 3, 4 sp3 orbitals. It's really important to look at how we are mixing four orbitals and we're getting out four orbitals, and this is called the conservation of orbitals, which means you can't like create or destroy orbitals. It's just pretty much mixing. So we form four orbitals. So mixing our 2s and our 3p's, gonna go here and make these four hybridized orbitals. And these hybridized orbitals will align on an axis that eventually form a tetrahedral shape. And that's where we get that methane is tetrahedral, and it shows that it has a bond angle of 109.5. So now we're gonna look at ethene, which is a double bonded carbon. So this is an example of a sp2 hybridized orbital. Um, So for this double bond, we're using sp2 hybridization, which means that it's mixing one 2s orbital with two 2p orbitals. So instead of this orbital, she'd be gone. So it'd be one 2s with the two 2p orbitals, which would make three hybridized orbitals, if that makes sense. So we'll take our s plus 2p's, which is going to make our three hybridized, which have much more p character. So yeah. So then we can look at ethine, and this is a triple bonded carbon. So we're going to mix one s orbital and one p orbital. So here we go again, but this one's gone. This looks really good, I know. So you're mixing one s with a p. No, one s and p. You're getting two hybridized orbitals. So what I like to think about when I am looking at hybridization, like looking at other molecules, I really like to see how many bonds the carbon is making, which will ultimately tell you the hybridization of the molecule. And if you're ever confused on like how many hybrid orbitals will make, it's really important to look at our numbers that we have here. So we have an invisible 1 in front of all of our s's. Also this p as well. If you add them together, it equals 4. So our sp3 has 4 hybridized orbitals. Our sp2 has 1 plus 2 equals 3 hybridized orbitals. And our sp has 1 plus 1, which equals 2 hybridized orbitals. So, yeah, that's just a little bit about orbitals. Yeah, that's it.